So, as for introduction, I'm Martin and welcome to my channel. I will be focusing mainly on educational content from areas of mathematics and computational geometry, but as for the fact that I'm professionally a C++ developer of, well, let's say meteor level at this point, I will be showing different ways in which I approach certain problems, and in contrast with most of the development content that you can find on YouTube, I think I should focus more on the duration of research and sort of share different pivotal moments of me trying to figure things out. You know, like when you're trying to find the most suitable framework for your problem or try to make the framework work with your system. I think those are things that you should learn and see, and you should definitely see how tedious and excruciating trying to make things work actually is in the developer's world. So, as for the first video, I think the most suitable example would be to already have a working piece of code. In our case, it will be a simple application with two classes and some utilities, and it will only contain two main classes, and that is a two-dimensional vector and a two-dimensional matrix, so that you can do all transformations in two-dimensional space. And we're not really sure whether this thing works because I haven't tested it in some sort of graphics environment where I can click and do transformations by mouse. This program is as simple as it can get, and I want to make sure it works. So I'm going to introduce a unit testing framework for my program. So let's get to it. All right. So the frameworks we're going to try are Boost, GoogleTest, CTest, CPP unit, and Catch, preferably the latest version, Catch 2. As for a little background on these, Boost is probably the oldest one of these, really extensive. It's a general multi-purpose C++ library that was developed as of 1999, but is used pretty regularly in various C++ systems. Then there's GoogleTest with, the latest stable release is from 2019, but I think the first commit is from 28. Yeah, 28. That's the initial commit of GoogleTest. It's just some text files, nothing really serious. But let's move on to the next one. C++ or CPP unit testing framework is relatively new, I would say. It doesn't have that many commits. I think the latest one will be from 2015. It's pretty new. So Catch is probably the youngest one of these. Let me see. Oh, it has a lot of commits. Let me find the first one. So it was probably renamed. So this wasn't the first version. And I guess the latest commit is from 2012. So historically, obviously the first one is Boost. Then there's GoogleTest. Then there's this one, Catch 2, and then CPP unit. Have I left one of these out? Which one have I left out? CTest. Yeah, CTest. I don't know much about this one, but because certainly looking, the oldest commit is from 2012. But most importantly, this one is directly supported by Kitware's CMake build system. So as far as I can tell, CMake is used pretty widely in many companies that are, even those that are maintaining legacy code at this point as of 2021. But I guess the heavy lifting is mostly done by DevOps teams in the companies. But if you're trying to make your own project work and make it work on multiple platforms, I think this is something that you should probably learn. And this is something that I should learn because I'm quite new to this at this point. So we are going to use CMake for making our application more versatile. So I'm going to create a very simple console application in Visual Studio, and it's only going to contain the Hello World basic example. But we want to change the folder structure so that it can run CMake. And I prefer to create a build folder that contains the solution and move all the remaining implementation and the source files in the source folder. Now, obviously, CMake needs so-called CMake lists, which are basic text files that contain the information about the project version, the folder structure in the project Visual Studio wrappers, and additional things like in C++ standard. So for this initial CMake lists, I'm just going to set the CMake version and name the project and give a version to it as well. And then I'm gonna set the C++ standards for 17, make it required. And then I'm just going to add a single executable from the main source file that was generated by the Hello World example. And now we need to generate the project files using CMake. I prefer to use the GUI version. We set the 64-bit platform, and now we configure and generate, and we can run the solution. We set the startup project, and it works. Now we can add more files. So we're going to add 5 more files, but I want to make them look like I've attached a library. So they're going to be in a separate Visual Studio project. So I need to create their own CMake lists with all the files included. I'm going to attach the directory to the main CMake lists via add subdirectory. I'm going to call it r2lib and target the link libraries to the main project. Now I want to edit the leaf CMake lists, create a project, set all the file names to the library. So it's going to be matrix to header, matrix to implementation, vector to header, vector to implementation, and vector utils. Now let's generate. I forgot to add the library in the leaf CMake list, so let's add it on top of that. Otherwise we won't be able to see our files that I've listed there. So let's generate one more time. And now we see the source files in our solution. So you can see the matrix here, and here are the CPP files with the implementation. Here are the util files with specialties such as geometry, dimension, tolerance, and coordinate indices. We actually had some build errors on the first try, so let's protect our headers with pragma once against redefinition, and we should be all set. Now, obviously, a trivial way to test the included components will be just to call them in our main function, where we will test our assertions. For example, here we want to test whether matrix vector multiplication actually works and produces correct results. So we create a matrix with these coordinates, and a vector with some other coordinates, and we want to test the results against the assumed results. The resulting x coordinate should be 1 times 1 plus -1 times -2, that's 3, and then the y coordinate will be -2 times 1 plus 0.5 times -2, that's -3.0. We'll actually test a specific function, and in our case it will be the multiplication assignment operator of matrix on vector. Now, one trivial way of testing this would be just to use simple if blocks with some return value, say 0 if it's successful or 1. And we can also do asserts. which only work in debug mode, and we need to include the cassert header. But they will do the job. Now, using this approach, we can pile up our unit tests in our main function. If we move all the testing to separate functions and just call them in the beginning of our main function. But this is obviously only a silly solution, because our tests aren't separate from our application and we will have to reinvent the wheel, inventing all the testing infrastructure handled by existing frameworks. Well, I kind of forgot to do the first step of test-driven development, and that is to make your test fail. So we're going to change one of the compared coordinates to have test failure. And we can see that our assertion actually throws an exception when it's retried in debug mode. Now, obviously, we've just been fooling around a bit, and we want to start the serious stuff. So we want to choose the unit testing framework that looks probably the easiest to me. So the first one I'm going to try is GoogleTest. And by far the easiest tutorial I found was by ReSharper team actually, and it made me install ReSharper so I can get new packages for my project and find GoogleTest and install it for my particular project. Let's see if this works. Now you can see the formatting changes because of ReSharper. And I seem to have some errors, which are, I don't know what they're caused by. Some compilation errors. So after a while I actually figured out that you can install GoogleTest as a Visual Studio component. So you can see it here in C++ development as test adapter. Now, after some trial and error, I figured out a way to actually include the GoogleTest to your solution as a separate GoogleTest project. And we're going to name it r2libtest. Now, we might want to attach the test project configuration as our library that we want to test, r2lib. Otherwise you would have to do that manually. Trust me, been there, done that. And now we include the classes that we want to test. So that will be matrix2 and vector2. And I think I need to attach the proper directory like this. Still doesn't work. Let me see. Oh yeah, that's the proper directory. So now I can actually include whatever I'm going to test. So I'm just going to copy paste the tests that I wrote earlier, the dummy test, and I'm going to use the assertions. So let me just move them to the expect equality macro from GoogleTest. And this should work. Let's rebuild the solution. Everything seems to be in order. And now in order to run the tests, I actually need to go to my test project and run unit tests. And I can see that the only test that I had actually failed because I had incorrect values in there. So let me change it to passing values and run the tests. I'll rebuild and run the tests one more time. And they're all green. So to comment on this a little bit, I think it should be said that the created project, the test project, was actually only created in Visual Studio, so it's not really connected to the whole thing. And if we run CMake, it will automatically remove all the connections to this new test project that I've created. So I need to figure out a way to make it work with CMake as well. Other than that, the problematic compiler errors that were present in the ReSharper version of GoogleTest were actually similar to those that I found here. And here in 2017, he said that he's going to deprecate the TR1 namespace, and this will cause this test to emit warnings, breaking builds under whatever flag is that. And a lot of people seem to be unhappy about this. And this was relevant for Visual Studio 2017 and for C++ standards 14 and 17. Now, I don't want to roll back my C++ standards because I like using various things that they allow me to do, and I want to move on to 20 as well. So this solution is completely irrelevant to me, and I'm not going to revisit it anymore, hopefully. For our purposes, let's just copy the example with artificial GoogleTest project from Visual Studio and remove the project folder so that we can recreate everything in CMake. And we're actually going to create a CMake folder for our test project. It's going to be in the same directory as the library that we want to test, right here. So it will be r2lib test. Now it needs a CMake lists and some executable, which we will call matrix vector test. Now, obviously we want to make sure that everything is connected. So, well, for now we're just going to clean up our main CMake lists and try to include the new node into our system. And after a few more hours of trial and error, I figured that the best manual is actually given by the documentation in the GoogleTest repository itself. Here we actually find an article incorporating into an existing CMake project. So we will actually use the last approach, which features this snippet of CMake code, which requires CMake 3.14 for this command to actually execute. So we're going to change our CMake required version, and we edit the new CMake lists node, creating a separate test project with name r2lib test version 1.0, and we copy paste the snippet in there. Now the executable name will be the name of the CPP that we have, and we also want to change the example to the name of the project here. Oh, hold on, actually the project should be r2lib test, but we will just use the project name variable. And here we actually remove the example here, so we don't need this, and put the project name to the test name as well, so as a command. And now we also want to change the link to an actual current repository. So just see that I actually copied the source link from the download zip file from the repository itself. And since we should have everything in order, we just run CMake one more time, and we should already have a GTest installed, just like in the case when we included a GTest project via Visual Studio. Now we move on to implement our test, just like we did in our previous attempt. And we should be able to include the GTest library, so we'll name it First one is the test case and then the test name. And we just copy the existing things. Now let's rebuild. And we will actually get 2019 linker errors, which are very similar to those that I found on this Stack Overflow post, where this guy didn't include the library that he wanted to test correctly. So we want to connect the R2lib library to our project, which we forgot to do. The test project doesn't recognize the R2lib, so that's why he actually throws these errors. And now when we rebuild, the build should pass. And just like the last time, we run the tests and they're green. Another useful thing to do is to move your fetch content call outside to the outermost CMake list, so you don't have to reinstall GTest for every test project. And you can actually ask if GoogleTest is defined. Now at this point, I'm not really sure whether the package name is saved in the CMake configuration files, and you don't have to sacrifice build speed, so that will be a question for next time. CMake, of course, supports adding tests as a post-build step, so you can see your test results every time you build. So far, I've only been able to attach the custom command to the test project because of its executable type. So you only see the test results when rebuilding the test lib or the entire solution. And that's about it for today. You've seen me learn how to set up Google tests for your C++ projects from scratch. And of course, I will move on to further frameworks in the following videos. I have definitely reached some dead ends. I have obviously edited out most of the mundane and unsuccessful attempts of me rereading available resources and trying to figure things out, but you've still seen me go through multiple iterations of the process. I hope that you're finding this very helpful, and if you wish to see more, feel free to subscribe, and of course, for the CMake and unit test geeks out there, feel free to leave comments and recommendations in the comment section below.